Welcome to this lightning talk on packaging LLVM snapshots as daily Fedora builds. My name is Konrad Kleine and I work for Red Hat as a software engineer. We're pleased to announce that Fedora users can now enable a packaging repository to get fresh daily builds of LLVM. This is something in the spirit of Debian's apt-llvm.org, where Silvestre does an amazing job. We built for the latest 3 Fedora versions, which are Fedora 34, 35, and Rawhide, which is our rolling release. You might ask why we even build snapshots. Well, we want to provide to the community as well as to our internal teams with newer LLVM versions. For example, our Red Hat internal kernel team typically needs a newer version than what we ship with Fedora for compiling the newest BPF programs. We also want to be aware of any problems that we might run into once our next official release date is approaching. The overall idea for this, in the beginning, was not at all straightforward, but now it is. All we do is leverage the way we build LLVM for Fedora. That is, we take a source tarball for each LLVM subproject and use that as our release. In order to learn from the snapshots, for our official release, we try to make as few modifications as possible. I mentioned earlier that we take a source tarball for each subproject as our release source. Now that means we're building each LLVM subproject in a rather uncommon standalone mode. You can find out more about this in the linked video at the bottom of this slide. But let me recap what it is and where we benefit from it. We built every LLVM subproject on its own so that it only sees its own source. Now, Clang needs LLVM to build, of course, and we resolve this by requiring the matching LLVM package to be installed when building Clang. Not building everything from one monorepository also means that we have to invoke CMake multiple times. As for the benefits, we see a reduction in individual build times, while the overall build time may be slower, in fact. This is because we use mock internally to have a fresh and clean build environment, and in there we repeatedly install the same dependencies for different LLVM packages. To give you an example, when we build compiler RT, it is in fact one of the fastest builds we have. It takes 5 minutes to build. Now, when we need to patch compiler RT, we build it in standalone instead of having to rebuild LLVM itself. This saves us hours of build time. The benefits apply mostly for our regular releases in Fedora, but also when a package breaks in the snapshots. I'm just stating that because I haven't invented standalone builds. As you may all know, our main branch in LLVM sometimes breaks, and we have build bots that notify or blame each individual contributor since the last stable build. Those same build bots, well, at least a few, they also report their status back to GitHub, and GitHub makes it extremely simple to inspect the status through their commit status API. The fact that LLVM lives in a monorepository is helpful as well. So the first thing we do is we go backwards through the commits in the main branch of LLVM and find the ones that pass the build bots that we're interested in. Look at the bottom 2 checks to understand what we're looking for. If one of these tests fails, we can save us a day of wasting compute resources. In Fedora, we maintain downstream patches for each LLVM subproject. Sometimes those patches are already submitted to Fabricator and wait for approval, and sometimes it's simply not suitable to have it upstream. Whatever the reason may be, a patch usually only has a certain lifetime. To make it easy for us, we maintain a clone of the upstream LLVM monorepository and apply our patches on top. Whenever upstream LLVM moves on, we might need to rebase our changes as well, and sometimes a patch is no longer needed. Then we walk through each subproject and generate the patch files to be stored along with our blueprints of how to build the packages. If you look closely at the name of the package that ends with RPM, there is a Git Shell 1 that indicates from which upstream LLVM revision this was built. For easier sorting and more human-readable versioning, we also store the date in a reversed order inside the version of the package file. Not only do we build for x86 64-bit, but also for PowerPC, ARM, Systemz, and x86 32-bit. This is a little bit of bonus material to explain what we use to make the snapshots. We have 2 scheduled Github Actions. Think cron jobs but flying at a higher altitude. One creates the snapshot releases that we use. The other kicks off the builds on our community platform called Copr. Grab your copy of LLVM for Fedora as long as it is fresh. Thank you for your time.